All right, everybody, here we go. Going through the final exam review, 62 questions. Going to be a great time, so buckle up. Okay, number one, determine if the quadratic has a minimum or maximum value. So again, this refers to, right, a minimum would be if it's a upward facing quadratic or parabola, and then maximum would be if it's downwards facing. So we're going to be able to tell that. Obviously, we could graph this, look at the graph. But we can also just tell this by this leading coefficient, this positive 2, because that's going to determine whether it is more of a smiley face or a frowny face, right? So positive 2 means that it's going to be more of a smiley face, which means this bottom point is going to be a minimum, right? So we know right away it's not B or D. And then, yeah, you can just look at the graph. All right, so we look at this graph, and again, it has that smiley face shape to it, and then this bottom point, the coordinates of that, can kind of comparing these. This is saying the x value is 1/2, the y value is -15/2 or -7.5. And this is the other way around. So x being -7.5 would be over here, and then +1/2. So that's not where it is. So we're going to go with answer A. And again, you can also go second calc, and your minimum value can be found that way too, specifically the exact coordinates. All right, number two, leading coefficient test. So again, leading coefficient is that coefficient of your highest term, okay? So the highest exponent here is a quartic, right? So it helps with these if you are familiar with the parent graphs, right? So this is a quartic graph. I'm not sure if you would have studied these or not, but again, basic shape of a quartic graph, it's kind of like a W type shape. So if we graphed it, it would look something like this, right? And the fact that this is +5 means that, yeah, it's going to be the same as the parent function, positive shape, just like the parabola here. So this is going to be similar to this. It might not look exactly like this if we graphed it, but it is going to rise to the right and rise to the left. So that would be C, but again, you could also just graph this in your calculator. All right, synthetic division might be one that we need to review. So if I have my thing here, right, we see we're dividing x squared plus 15x plus 46 divided by x plus 6. So again, first synthetic division, we're going to set up a little box type thing here. This value right here, we flip the sign around, -6, and that's the value that goes outside of my box. And then in here are the coefficients of the top of what I'm dividing. So 1, 15, and 46. And so synthetic division is kind of a cycle, right? So the cycle begins by dropping down our first value, 1, and then we multiply that value by this outside number. So -6 times 1 is -6. And we put that answer right there. And then we add that value, 15 plus -6 would give me +9. And then my cycle starts over. -6 times 9 would be -54. I combine that with the number above it, so 46 plus -54, -8. And then I'm all out of numbers, so this one isn't too long. But again, what do I do with that? Well, again, I think about my highest exponent on an x term. There is a 2, and then in my bottom of my fraction, it would be a 1. So an x squared divided by an x would just be an x to the first, so this would be a linear answer. And I just kind of go down from there. So this would be 1x plus 9x to the 0, but I don't really need to write that. And then this right here is my remainder, okay? And I put my remainder over what I'm dividing by. So that would be my answer right there. And so I look at my answer options, and that's going to coordinate with letter D. Okay, and then long division is another way to divide polynomials. Okay, so a little bit more complicated. So again, I set this up just like I would set up like a long division of just numbers, like you would have done in elementary school. And I ask myself, yeah, like how many times would 3x go into -12x squared? Or you could also think like 3x times what would equal -12x squared? Sorry, that should actually be cubed. My fault. So how many times does -3x go into -12x cubed? And that would be, you could say -4x squared times this would equal -12x cubed, right? So we multiply this times that once we figure out that value. So -4 times 3, -12. X squared times x to the first, x cubed, right? And that is ideal when we can get it to match exactly after we multiply. But then I also need to multiply the rest of it, right? So -4x squared times this -2 would give me +8x squared, okay? And so I multiply those, and then I'm subtracting here. That's a big deal that kids forget about, is that we subtract these, right? Not adding like synthetic division, but we subtract. So it's going to be -12x cubed minus -12x cubed. And those will actually kind of cancel, right? Because that's the same as negative plus 12. And so that's going to cancel. And then I think 20 minus 8 would give me 12x squared, positive 12x squared, right? And then the rest can come down. And then I do the same thing. I ask myself, how many times does 3x go into 12x squared? Or again, 3x times what would equal positive 12x squared? And so that should just equal positive 4x, right? Positive 4x times 3x. So 4 times 3, 12, x times x squared. Then same thing with the other part of the thing I'm dividing by. So 4x times negative 2, negative 8x. So again, key here is that I'm subtracting, right? So 12x squared minus 12x squared, nothing. 7x minus negative 8x. So I wouldn't say negative 1, I would say 15x, right? Minus negative 8, same as adding 8. And then bring down my minus 10. Then this one's nice because it divides evenly, right? Because I think 3x times what would equal 15x? That would equal positive 5, right? 3x times 5, 15x. And then here's the key, 5 times negative 2, negative 10. This last part cancels out too. So when I minus these, 15x minus 15x cancels, negative 10 minus negative 10 cancels, left with nothing, no remainder. So that's my answer right there, 4x squared plus 4x plus 5. Okay, A, C, D, B, first four. Okay, find the rational zero of the polynomial function. So zero is just vocabulary here. Zero means x-intercept, right? So with a lot of these, yeah, looking at the graph is going to help us, and definitely with this one too. So let me put this in my calculator, graph it. And so we got our graph kind of working out there, and so we want to look for where does this cross the x-axis? Okay, and we can kind of just visualize and see, right? Sometimes you have to change your window to see it on the graph, but again, I see maybe like -3, -2, +2. Again, if you're not quite sure exactly of where, you can also go second table and look at a table of values. It's whenever this y value is 0, right, that it crosses through the x-axis. So +2, -2, -3. Yeah, that looks right. So -3, -2, +2, that would be answer option B as well. All right, number 6, 2x over x plus 2. This is a rational function. We're asked to find the domain, right? So domain, the big deal with these next like 4 problems is that the denominator cannot equal 0. We want to avoid any x value that would make that denominator equal to 0, right? Because that means we're dividing by 0, and that's no good, right? So that's my big question is what x value would make that denominator 0? In this case, -2, right? If x was -2, -2 plus 2 would be 0, and that's no good, right? So basically, x could be anything else besides -2, and that's what answer C is saying. It's saying x can be anything except it cannot equal -2. And then the same thing with number 7, right? We kind of have these two factor groups, and I'm thinking with this, if either one of those, right? Because it's saying these two factor groups are multiplied. So if any one of these factor groups was 0, it would be 0 times whatever, and it would be 0. So I want to think what x values would make either one of these groups 0. So +1 minus 1 would equal 0, and +6 minus 6. So can't be 1, can't be 6. And so that would be answer option B here, right? Can't be 1, can't be 6. All right, then number 8, x minus 2 over x times x plus 1. Vertical asymptotes. So these are connected because the domain is saying what x cannot equal. And then when we look at these graphs, if we actually graphed these, that would be the reason x can't be these. And on a graph, that would mean that there's a vertical asymptote there. Like we kind of just generally, these graphs can look very different. But if I had like a vertical asymptote here, a lot of the time it'll kind of go like that. And then like that. Again, that's not what this exact graph looks like, but they usually look something like this, right? So x kind of goes right up to that and then does not go to this value exactly and then continues, right? And so this is the same question basically is what I'm trying to say, is that's what would make the denominator equal to 0? And it's those x values that usually result in a vertical asymptote, right? Sometimes there can be holes as well, but I don't think there'll be any in this case. So it would end up being C, right? This outside x could be a 0, and it would be 0 times the group, and it would be equal 0. Or -1, right? If x was -1, -1 plus 1 in the group would be 0, and it would turn into a 0 down there too. So answer C for that one. And again, just look at the graph. If you forget this rule, just graph these, and you can see where the asymptotes are that way. All right, picking up with my second page. Number 9, same idea. Where's the vertical asymptotes? Let me actually pull up the graph on this one. So there's my graph. It doesn't look like a whole lot's going on, and there's not. But the big thing here, again, what would I be looking for is those places where it kind of goes down and then comes back up from the top. And I don't have that kind of, if you zoomed in, you'd see it's a tiny little wave there towards the origin, but no vertical asymptotes, right? No vertical asymptotes. And again, with holes, I would look for, is there an X factor or a factor that can cancel on the top and bottom? And there's not. So in this case, there would be D, no vertical asymptote. All right, now we're switching over to horizontal asymptotes. So again, fallback strategy, if you don't remember these rules I'm about to say, is just graph it in your calculator, visualize it, look at where it is, okay? For horizontal asymptotes, there's some rules though, right? When we look at the fraction, right? In this case, the degree of the top is less than the degree of the bottom, right? The higher exponents on the bottom of the fraction. And there's a rule with that, right? There's going to be a horizontal asymptote always at y equals 0 when that happens, when the degree of the top is smaller than the degree of the bottom. So y equals 0 is that. And then for the second one, in this case, like I look at my exponents, and again, they're kind of equal. The degree of the top is equal to the degree of the bottom. So in this case, I have to do a little bit of math. Okay, so I look at my leading coefficients. Okay, so 6x squared, 2x squared. So that would be the top over bottom leading coefficients. Okay, you could say LC for leading coefficient. So the top over the bottom leading coefficient. So 6 over 2 would be 3. Y equals 3. So that would be A in that case. That would be the location of that vertical or horizontal asymptote. Okay, now switching gears, number 12, we're talking about variation. Okay, so variation. Direct and inverse, two different types, right? So the big thing with this is you remember the equations associated with them. They're very simple. Direct means multiply, y equals k times x. Inverse means the inverse of multiplication, which is division, right? So y equals k over x. And kind of a two-step process here. We need to find our k value, then we need to use that k value to answer the question it's asking for at the end. Okay, so we find our k value by substituting in these values they give me in the first sentence. So it says y varies directly as z, and so it's always going to go right in order. So y varies directly as z. So in this case, it would actually be y equals k times z. And then it's saying y equals 132 and z equals 11. So it would be 132 equals something times 11. So I just divide 132 divided by 11, and I would end up getting 12. So that's not my answer. You see that 12 isn't an answer here, but I'm going to use that, right? So now I know my equation is y equals 12 times my z value, because k is 12. So I would just do, in this case, find y when z is 18. It would just be 18 times 12. And you can see 18 times 12 ends up giving you 216. So answer C for this one. And then the same thing with 13. X varies inversely as v. So again, just kind of changing my letters around. X equals k over v. So it says x equals 14 when v equals 8. So 14 equals k over 8. So I multiply 14 times 8 in that case and get 112. So k is equal to 112. Again, not my answer, but I can use that, right? Because it's saying find x when v is 16. So that's saying x is equal to 112 over 16. 112 over 16 gives me 7. All right, now 14, 15, and 16, very simple. Just you can, again, it says approximate, but you have your calculators, right? So no purpose in, it's good to be able to estimate in your head, but again, just these should be easy ones to get right in the calculator. So about 12.99 for that one. Letter D, 15 to, again, just remember exponent, that little caret button, negative 1.2, so about 0.435. D, and then 16, 5 to the square root 6, square root second x squared. We get about 51.537, so that would be answer A. All right, so number 17 is asking about a function with E, right? So just reading through that, right? It's asking how many milligrams based on this equation will be present after 5 hours. So it's saying h is hours, right? And so this is just as easy as taking this function and substituting in 5 in there, right? And so you can just substitute that all into your calculator. So that would be 6e. See, e to the x is second natural log. So 6e to the negative 0.4 times 5. And when we do that, we get an answer of about 0.81, 0.812. So that would be answer A. All right, then looking at 18. So now compound interest, right? You have the two formulas given to you here. Again, just remembering that PERT is used for continuous compounding. And this one's used for basically any other type, right? The difference is this has a number of compounds per year. So quarterly would mean like that n is equal to 4. And again, our other variables are for rate, t for time, p for principal, meaning like a starting amount of money. Rate, just remembering putting rate as a decimal, so 16%, 0.16, 0.16, sorry about that. And then, yeah, t is time, so that'd be 4 years. So you just substitute all that in. So let me write this with all that in there. So you can see p is 1400, rate is 0.16, and number of times compounded in a year is 4. And then that same number, 4 for n, and then t for time, 4 years. And then, yeah, just no variables in there to solve for, right? So we can just straightforward plug that all in. So we substitute all of it in, right? And we get about $2,622. So that would be answer option C. And then another one of those on the back here. Now this, again, reading through continuous compounding. So this is going to be our PERT, P-E-R-T equation. I actually wrote that wrong. It's R and T both in the exponent position. So again, P, initial amount of money. R is rate as a decimal. T is time. And that's to the E power, right? E not a decimal, but that number, about 2.7 that we can, that we're just going to put in as E into the calculator, right? So that would be 4,000 times e to the 0.08 times 6 power. Okay, again, substitute all that in. So 4,000 e to the 0.08 times 6 power, about 64 and 30 cents. So 64, 30. Be careful, read carefully, right? Because that says 65, very close. They almost got me with that one. Okay, number 20, write this logarithm in exponential form, right? So again, I've said this all year, the answer to a logarithm is the exponent, right? B is the base, so this is the same as b squared equals 9a. B squared equals 9. The answer to a logarithm is an exponent, right? B is the base, 9 is the answer to the exponential, right? Now you can just go the other way, right? Just keep telling yourself that as you do this. The answer to a logarithm is the exponent. So this is going to equal 3. 5 is the base. X is my answer to the exponential. So log base 5 of x equals 3. Now evaluate the expression. So again, you want to make sure on the final that you have a calculator that can do log base, right? So if we go math, down, log base right here, right? This lets you type in a custom base here, right? You should be able to evaluate this first one without this probably, but it's fine. So this, again, the answer to a logarithm is an exponent, right? So this is saying 4 cubed equals 64. And again, or again, if you know what you're doing, 4 to what power equals 64? That's what you'd ask yourself if you didn't need the calculator, and that would be C. And then same idea here. This is saying 10 to what power? So 10 to what power equals 1,000? And that would also end up being 3, right? Again, you can use your calculator. You could actually, if you use your calculator for that, you could use the normal log, because again, the standard, and so that you're just using your log button right there, because the standard default logarithm has 10 as the base, called our common log, right? All right, 24, graph of the logarithm is given, select the function. So again, in this situation, guys, just graph each of these. Just the things to notice, again, a standard logarithmic function looks like this. Again, always goes through 1, 0. So again, you notice, kind of, if you're familiar with the parent function, this is flipped horizontally, right? And so you think about, okay, what must have been added in the equation to make it flip horizontally? If there's a negative out in front, that means that it was flipped vertically, so it would kind of go upside down from this blue one, right? It would be kind of going down like that. This would end up being B, right? So the negative in with the X means a horizontal flip, and that is the change here from the parent function. That's what happened. And again, you can just get that too by just typing each of the, if you didn't know right away, just type each of these in your calculator, find the one that matches. Okay, find the domain of the logarithmic. Now with this sort of thing, anytime it asks for the domain, it is helpful to see the graph. So I'm going to graph this, okay? So we have natural log of 4 minus x. And if you know what you're doing, you might know what this graph looks like ahead of time. So there's my graph going right there. And then again, I don't know why the calculator does this. It would continue kind of down like this, okay? But again, what domain x values, right? So what it's asking here, what are all the x values that this graph would go to, right? So It's coming in from the left. Again, you could zoom out if you don't trust it. It would kind of go forever here, go to negative infinity on the x, and then it would go, 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 and then there would be this horizontal asymptote. We can kind of confirm that right at 3, right? Well, it touches 3, 0, but then 4, right, is where it begins to have an error. So we can even see, looking at the graph, it goes to 3, even like 3.5, 3.8. But right when it gets to 4, again, I don't like how the calculator visualizes this. But yeah, it would have an asymptote there at 4. And so negative infinity to positive 4 would be a good answer for that. Okay, now this one, evaluate or simplify the logarithmic expression. So again, this is another one, calculator can come in handy, right? There's ways to simplify this without that, but now again, can be hard to tell. This would be common log with a base of 10. But let's just go in the calculator. 8 times common log of 10 to the 3.8 power. And so we get about 30.4 b. So again, all right, so now looking at 27, this is another one where we're just going to end up being able to throw this all in the calculator. So the long jump record at a school is modeled by this equation. X is number of years. It's saying, what is the record in the long jump? 18 years after the record, right? So this is why it's important to look at what it's asking in a word problem and tie that with a variable, right? So either it's going to be giving you a y value or an x value. And so again, x is the number of years. So we know by giving us 18 years, that's an x value that I can substitute in. And again, that's kind of my variable right in here. That's the only one. So that means I can just substitute all this into my calculator. So 18.1 plus 2.3 times natural log of 18 plus 1 is 19. So I can just do that math myself. So about 24.87, or rounded up 24.9 feet. Don't know how that compares to the Mount Lebanon school record, but it's an impressive jump for sure. All right, properties of logarithms. Okay, so again, properties of logarithms, kind of going over these with you. Okay, so, and that's kind of nice. We'll be able to go over all these kind of generally here. So log base 3 of 9x. Okay, so we have something like this. This product rule of logarithms kind of says if I have a log of something raised to a base of 2 things multiplied, what I can do is kind of write that is log base 3 of 9 plus log base 3 of x. Kind of those 2 things multiplied there. Okay. And then I'm going to be able to simplify that, right? Because log base 3 of 9, again, what that's asking is 3 to what power equals 9? And so this would equal 2. Okay, so 2 plus log base 3 of x. And I can't simplify that anymore because that is a variable in it, but it matches up with my answer option B. All right, and then the second one is the quotient rule, kind of similar to this one. This is saying log base 5 of 5 over x. So very similar to this, like I said, when it's a log with common base, or the one base, and it has 2 things divided, a fraction, I can write that as 2 separate logarithms with that same base, but just with those things being subtracted. And so I can separate them like that, still the same base, the 2 things, top of my fraction first, bottom of my fraction second. But again, looking to simplify if I can. So this again is saying 5 to what power equals 5. And so this would equate to 1. So this would be 1 minus log base 5 of x. This log there, C is my. All right, and then 30. This one is called the power rule, last one. Okay, so log base 7 of x to the 8th. So we talked about how when there's a logarithm of something raised to the exponent, that's the same as writing this exponent can be moved out front as a coefficient. So this would be the same as 8 times the logarithm of 7 to the x. Okay, and I can't really simplify that any further, but that would go with letter D here, right? So that's how I simplify those logarithms using my 3 rules. All right, now 31, 32 are kind of going the other way, where we want to condense, right? So still keeping these rules in mind, right? So when we have 2 separate logarithms, same base, right? Keep in mind what I did here. This is the opposite. I went from here, I separated them with addition. Now I'm kind of going here, and I want to do this, right? I see that it's 2 things with the same base being added. That's the key. That's how I know it's going to be multiplication in here. So this means it would be log base C, that same base, of t times s. Log base b of t times s goes with the answer option B. And then same thing with 32, but look, 32 has something extra too, right? Two logarithms, same base, subtracted, so that's telling me there's going to be a fraction involved. And I mean, even knowing that, you might, well, you know, at least it's going to not be B or D. This has division, but not how we write that. We write it as a single logarithm, right? But again, notice coefficient out in front here, right? Coefficient. So condensing it would mean kind of, again, just doing the opposite of what I did up here, moving that coefficient back up into the exponent position. So it would be kind of log base b of q squared, okay? And then writing it as a fraction. So log base b of q squared over r. And so that would go with UC answer option. Okay, now I want to solve 33 for x, okay? And so for this one, again, we see that it's an equation. My x is in my exponent position. And so again, the way that I deal with that is to use a logarithm, okay? So it's in exponential form right now. I'm going to write it as a logarithm, okay? Because again, the answer to a logarithm is the exponent. So this is saying log, if I wrote this as a logarithm right now, log base 2 of 32 equals my exponent 1 plus 2. And so now that x is out of the exponent position, I can solve for it, but I can evaluate this here too. Because again, that's saying 2 to what power equals 32? It ended up being 5. So this log base 2 of 32 would equal 5. Okay, and again, throw that in your calculator if you don't remember. But then now we just have a simple algebra 1 equation to solve here, right? Minus 1 to cancel that, so 2x equals 4. And then you divide, so x would equal 2, and that would be answer C, right? All right, now for this one, solve the exponential equation, same idea. Express the solution set in terms of the natural logs. Okay, so it wants us to use natural logs here to solve, okay, and we can do that, right? Our rules of equations, just we can really do whatever as long as we do it to both sides of the equation. Okay, so like for this, again, the only way I can get my x out of the exponent position here to solve for is to use a logarithm. So this one I kind of converted using that. Another way I can do that is just take the natural log of both sides. And then my power rule of logarithms is going to allow me to solve for that, right? And so I can move this x plus 8 out here, okay? Because again, it's logarithm of something with an exponent. So again, that power rule allows me to move that out front. So that'd be x plus 8 times natural log of 3 equals natural log of 4. Okay. And now I just want to think, how do I get that x by itself? And so again, right now, this x is being multiplied by this natural log of 3. So I can divide that, cancel it, divide it to the other side. And again, you can see the answers, normally we could like get these into decimals and kind of get a single value, but it's having us keep it in terms of natural logs. So we won't simplify these. So it's just x plus 8 equals natural log of 4 over natural log of 3. And then as you can see, right, I need to cancel out this plus 8, so I would just do minus 8 over here. So x would equal natural log of 4 over natural log of 3, kind of that whole fraction, and then the minus 8 separate from that, okay? And so that would go with answer C. All right, now with this one, natural logs are more practical when an e is involved, because that can kind of take care of itself. So you won't have a messy answer like this. So yeah, I would do the natural log of both sides. And again, still apply my power rule. Natural log of e to the 4x, natural log of 6. So move that out front. 4x times natural log of e equals natural log of 6. And we're just saying, again, natural log has a logarithm with a base of an e. So it's saying e to what power equals e? And so that will just be 1. So the natural log of e just equals 1. Okay. So this is the same as 4x times 1 equals natural log of 6. And we know that anything times 1 is just itself. So really my last thing I have to do is just kind of take care of this 4, divide it. So yeah, that would be natural log of 6 over 4. You see answer D there matches up with that. All right, so 36 is going to involve a little bit of work because it's going to involve us moving backwards and solving for a variable. And so again, just reading through, it's an investment. There's this exponential equation. T is the number of years, right? So you see that's a variable here. But it's not saying like how much will the account be worth in 10 years, right? That would be like substituting in 10 in for T and kind of just throwing it all in the calculator. This one we have to work backwards because it's asking when, which implies t, what number of years, when will the account be worth this much money? So it's kind of giving me this this final amount of money, and I need to solve for t. So it's going to be similar math to what I did in the last problems where I want to get rid of that um, exponent using a natural log. But first, so let me just write this out. So there's my equation. And so again, I need to solve for t. And so what I'm going to do first, again, I don't want to take a natural log till it's all simplified. So I can divide out that 6,700, dividing because again, it's being multiplied by the e. And if I do that math, you see I get about 1.41. Rounding here shouldn't throw off your answer too much. So that's what's left, right? And so from this case, again, it's similar to the problem I just did where I can do the natural log of both sides, right? And again, power rule says I can move that exponent out front of my logarithm and it's equivalent. And then, yeah, this natural log of e just equals 1, right? So it essentially just goes away because that's the same as times 1. So really, I just have 0.057t equals natural log of 1.41. And again, you could wait till the end, like if you just wanted to keep it as this fraction, you totally could do that because you would get a more accurate answer if you did that. So I would just need to do the natural log of 1.41 divided by that decimal, that 0.057. If you did that, you get about 6.02. So yeah, we're going to round that down to be about 6, right? And so again, you don't see 6 as an answer option here, but again, it's saying years after 2000, right? So that would be D 2006, right? That's 6 years after 2000. So answer option D goes with that T answer of about 6.02. All right, switching gears big time here. Now we're going to angles. Again, angles in standard position, just reviewing that with you here real quick. Again, standard position means I have a graph. Again, standard position just means like starting from your initial side here being the x-axis. Then if I'm graphing like a 100-degree angle, right? So you go a little bit past 90 and maybe your terminal side would end up about there. So that would be, that would be just a quick review of graphing in standard position. So a negative 207-degree angle, again, just kind of picturing this. Again, initial side starting here on the x-axis. And then again, if we're going negative, that means clockwise, right? We're going down first. And now you need to kind of think about this. If I went halfway around, that's 180 degrees. Or going this way, that would be negative 180 degrees. So it's going to go a little bit beyond that, right? So negative 207 maybe would take me to about there. And again, it's not asking exactly where it is. It's just saying what quadrant. And so that would lead me to quadrant 2, which again is answer option D. All right, so now 38 is asking us to find the radian measure of an angle and when we're given the radius and the arc length. Okay, so again, just formula to know with this would be that arc length, I guess they're using S here, so I'll use S instead. Arc length S equals the radius times the angle. Okay, but again, this angle being in radians. So it's nice that when we get an answer here, it'll already be in radians for us. So basically, we just need to substitute in, right? So if our radius is 3.1 and my arc length is 10.54, I just need to divide those two numbers. I just need to do 10.54 divided by, now you see, give me about 3.4, a little over 1 pi. Normally, radians are in pi, but not in pi in this case, so that's fine. All right, then 39, convert the angle in degrees to radians. So again, converting to radians involves multiplying by pi over 180. So it'll be 135 pi over 180. There's a common factor of 4 there. So that would be 3 pi over 4 radians, or answer option B. You also have your unit circle, right? So 135 degrees, 3 pi over 4 radians. So a little bit easier if you just look at that unit circle. All right, so now convert the angle in radians to degrees. Okay, so now you won't find this on your unit circle, which is why you need to know still how to do this. But going the other way involves just multiplying by 180 over pi. Normally when we write radians, it's 11 pi over 8, like the pi's on top. It's still going to cancel even though it's written like that. So I would just need to do 11 times 180. So that'd be 1980 divided by 8, which would be about 247.5 or about 248 degrees. Answer B. All right, now we're talking about coterminal angles. Okay, so again, kind of just remembering this word, right? Coterminal angle means that, so if I have a 45-degree angle, I could also say that a 405-degree angle is coterminal with that, because it still ends up in the same place, just it takes one extra loop around the circle there to end up there, right? And again, the difference between these is that you can add or subtract, like 405 plus 360, right? That's the key, is their coterminal angles are 360 above or below one another, right? So 41, super easy to find that when you know that, right? Because it's just 509 minus 360. So that would be about 149 degrees. Answer B. And then same thing with 42. Now this is negative, right? So you could draw that, but again, just easier. Basically, what you do here is you keep adding 360 to it. Or again, if you know your multiples of 360, you can kind of save yourself some time. But you need it to be in that it's positive, but it's less than 360. So like a 0 to 360 degree range. Or if it's in radians, 0 to 2 pi radians. So negative 82 is not quite there, so I add 360 again, 278. Okay, so 278, answer C for that one. All right, 43, find the length of the arc on the circle. Now again, keeping in mind our arc length equation, right? Arc length is this, so it's just this times this, but again, needs to be in radians, our angle, right? So that would be my first goal, is get this 25-degree angle in radians. So I would need to do, I'll do this down here, 25 times pi over 180. And so 25 pi over 180. And again, guys, shortcut to reduce fractions, 25 divided by 180, get a decimal. You can go math, turn that into a fraction. It'll fully reduce it for you. So about 5 pi over 36. So yeah, if we do it with pi, right, so we get about 0.436 as my value. So that is the numerical value, not in terms of pi, of the number of radians that 25 degrees is equal to, about 0.436. So then I times that by 60, so I get about 26.17, 26.18. So that is answer C. All right, so last one here, 44. This one's actually pretty simple. So angular speed just has to do with how many, radians per second, right? But it's typically given to me in revolutions per second. So the key thing here, guys, is that, again, one revolution around the circle is equal to 2 pi. So that's really the key value here. So if I'm told that something is moving 60 revolutions per second, the way that I would get that, right, that's kind of saying one revolution is just equal to 1, right, when it's not in radians, but in radians, one revolution is equal to 2 pi. So I just basically need to do 60 revolutions per second times 2 pi, give me the number of radians per second, so that'll just be 120 radians per second. So that's a little bit different than ones we did in class, but you can see it's just super simple, right? Revolutions equal to 2 pi, and so 120 there. Okay, so this is saying use Pythagorean theorem to find the length of the missing side, then find the indicated trig function. Okay, so Pythagorean theorem, right? 2 squared plus 7 squared equals c squared. C, my hypotenuse across from my right angle, so that's my missing side. So it'll be 4 plus 49 equals c squared. 53 equals c squared, so c equals the square root of 53. That's my hypotenuse. So then from here, I want to think about, like, okay, how would I write cosine? Cosine equal to adjacent. If this is my theta angle, adjacent 7 over hypotenuse squared 53. But you can see here that that's not an answer option, because again, we talked about, guys, how you want to rationalize your denominator, and that's what these answers are given as, with rationalized denominators. So again, what that means is you take your fraction with the radical in the denominator, and you multiply the top and the bottom by that radical with the same number inside. So you do square root of 53 over square root of 53, multiply by that, and so the top is just going to be 7 times that square root. But then the square root times the square root of something times itself, the radicals kind of cancel, so you're just left with 53. Okay, so you can see that goes with answer A. All right, and then so theta is an acute angle, and sine and cosine are given. Use identities to find the indicated value. Okay, so trig identity. So guys, we're looking at 46, and for this one it's saying it's an acute angle. So it's good to know. So that it's between 0 and 90, right? That's what that's saying. Here's what I would do for this. I know it says to use identities, but I think this is simple, right? It's asking us, so to be able to find the tangent, I need to know what angle it's talking about. So that's my first task here, is to find the angle. And in this, just think about this. You're given sine of theta equals 2/7. Okay, so we talked about how if you know the sine of the mystery angle, if you know that value, you can reverse that and do the inverse sine of that to find the angle measure, right? So that's what I would even say. That's a little bit simpler. You can see second sine of 2/7, and sum told us about a 16.60 degree angle. Okay, and now I'm asked to find the tangent of that, right? So I can just do tangent and do second answer to get that exact angle in there. And so I get about 0.298. Okay, and again, now it's just figuring out, because I'm not told any of these are 2.98. So what you could do here, right, this is about 3.5, so that can't be it. What you could do in this case then is just evaluate these fractions. So you see answer option A, 7 square root of 5 over 15. Not the same. Hey, there you go, 2 square root of 5 over 15, same value, same decimal answer as your thing there. So that's kind of a workaround way of doing it, but I just think that's a good guess and check way to do that. All right, so this is actually take 2 for number 47 for me. I misinterpreted what it said the first time, so let's do that again. So we have a radio transmission tower that is 160 feet tall. So there's my tower. How long should a guy wire be if it is attached 5 feet from the tops? Okay, so here's something, right? This whole thing is 160 feet tall, but if a guy wire is attached 5 feet from the top, this length would be 155, not 160. The whole tower is this, but really, because my wire is going to be going from here to the ground, and so that's what I'm wondering. How long is this wire supposed to be? That's what it's asking. How long should a guy wire be if it is attached 5 feet from the top and is to make a 26-degree angle with the ground? So on the ground here, it's going to be a 26-degree angle. So again, kind of think about where are these sides in relation to this angle? So this is the opposite, this is the hypotenuse. So my equation I could use to set up here would be sine of 26 equals 155 over x. Okay. And again, solving for x, I could times over this x. So x times sine 26 equals 155. And then divide out that sine 26. So x equals that 155 over sine of 26. Or 155 divided by sine 26. 353.58 or 353.6. Answer option B. All right, 48 is kind of a weird question, right? 1 plus sine squared 35, sine squared 55. This, to be honest, guys, this is just calculator. So 1 plus sine, and you type it in your calculator differently than this. This wants you to square. We actually type the angle in first and then square it, okay, into the calculator. So sine 35 squared, sine 55 squared. So 2B answer. Okay. Point on terminal side of angle theta is given. Find the exact value of the indicated trig function of theta. Okay, so a lot of work to do here, guys. So again, just things to consider here. I have a graph. Okay. The point that it gives me is 18, 24. So maybe like right there. Again, what does that tell me, right? If I'm kind of putting together my triangle on my coordinate plane, that's what it would look like. If that's my point, again, consider this. That's my x and y coordinate. That's also the length. This is the y length and the x length. Okay. I need to know my hypotenuse, especially because it's asking for cosecant. Cosecant is the reciprocal of sine, right? So if sine is opposite over adjacent, or in this case, y over r, cosecant would be r over y, and r being another word for my hypotenuse. So I need to find that hypotenuse, just Pythagorean theorem, and then I need to do that hypotenuse over my y coordinate. So I know it's going to be something over 24, but again, you see these are reduced, so I'll end up having to reduce. So Pythagorean theorem, 18 squared plus 24 squared equals c squared or x squared or r squared. Lots of letters you could put in there. 18 squared plus 24 squared. So how about 900 equals c squared, and then take the square root of 900, you would get 30. Okay, so c, my r, is equal to 30. So what does that mean? That means my cosecant value is going to be equal to 30 over 24. And I can reduce that common factor of 6, divide those both by 6. I'll get 5/4. So answer option A. All right, two more on this page. Number 50, cosine of theta is 4 over 7. Tangent of theta is less than 0. Find the sine. So some more work to do here, similar to the last one. Again, when I'm given cosine, I'm given an x value and the radius. So if I'm given 4/7, x is 4, the radius is 7, or my hypotenuse, I need to know my y value. Okay. And the fact that it's telling me tangent is less than 0, what that helps with is, again, my all students take calculus, my values where my trig functions are positive. So if tangent's less than 0 and cosine's positive, that can mean two things. That could mean it would either be in quadrant 1 or 4, okay? Because if tangent's less than 0, can't be there. Okay. Cosine is not positive in quadrant 2. It is positive in quadrant 4, and everything's positive in quadrant 1. Okay. But I get clued in here with my answers, right? You see all my answers here are negative, which means it can't be in quadrant 1. There's no negative values there. So it has to be in quadrant 4, my point. Okay, and then what that helps with is, again, my y value should be negative. Okay. And if I want to sketch this out, right, so I would have a point here. I know my radius is 7. I know my x value is 4. I need to know this y side right here. Okay, so again, that's quadratic formula, right? I know two sides of a right triangle. 4 squared plus y squared, or b squared, however you want to say it, equals 7 squared. So that'd be 16 plus y squared equals 49. 49 minus 16 would be 33. Y would equal square root, but again, negative square root 33. It's negative because, again, it's in the fourth quadrant where the y values are negative. Okay. So again, what is it asking for? It's asking for sine. Okay, so sine is going to equal the y value over the radius, right? So I know my y value is negative square root 33, and I know my radius is 7. So negative square root 33 over 7, answer option B. All right, find the reference angle for the given angle, 423 degrees. Okay, so again, picture this. Reference angle is not the same as coterminal, okay? So you don't just do, well, we'll end up doing that minus 360, but for a different reason. So just picture it, right? A full rotation, positive, would take me here. And so I have to think, okay, how much more would it go beyond 360? So 423 minus 360 would give me about 63. We actually see my answer option given there. But again, that is not why. It's not just, it ends up being the same as the coterminal angle. But again, a reference angle is this idea right here. It's how far, what's the closest acute degree distance that terminal side, where it ends up being, back to the x-axis. Okay, so in this case, yeah, it is 63, but it's not, you don't just always do that to find it. Okay, there's different ones. All right, so this one, use reference angles to find the exact value of the expression. Okay, now a couple options here. Again, saying to use reference angles, you don't have to. There's no way for us to check that you are using reference angles. But 452, again, it's asking about the angle 7 pi over 6. We know that equates to a 210 degree angle, but what it's asking for specifically is the tangent value, okay, of 7 pi over 6. So again, tangent is y over x, and specifically it's my numerators, because, right, the denominators all are 2 and they kind of cancel out. So that would be -1. So the tangent of a 210 degree angle, or 7 pi over 6 angle, would be -1 over negative square root of 3. But again, a couple things we can do here. They're both negative, so that would equal just 1 over square root of 3. And again, you can also see my denominator is rationalized, so that's multiplying it by square root of 3 over itself. So that would be square root of 3 over 3. Answer C. All right, so again, this is saying it corresponds to a point on the unit circle, just meaning that it's between 0 and 360. This would be a point on there. Again, obviously, if we look at the coordinates on my unit circle, we won't find these. But the important part is that that's an x and a y value. If we don't need to know where this exact angle even is. Just sine of whatever angle equals the y coordinate. Okay, so whatever the y coordinate is, that's what sine is. So whatever that angle is, however many degrees. Now cotangent's different. Cotangent, right? Tangent was equal to x over y, or y over x. Cotangent's equal to x over y. So when I'm given this, right, these values, again, x equals negative 39, square root of 39 over 8, y equals that. So what I would need to kind of do is, again, and look at this too, just like on the unit circle, the numerator or the denominators are the same. So when I think about this for cotangent, I almost don't even need to write the denominators. So that would be the x value, negative square root of 39 over 5. Okay, so you see that corresponds with answer option. Okay, now it's getting into trig graphs. Okay, so what is the range of the cosine function? Again, you remember your cosine function. Look at the graph if you forget. Again, our cosine function, how we drew it in class, starting up here, going up like that, right? But it would continue in that same wavy pattern, right, as you went. But again, the range, the y values of this, right, goes up to 1 down to negative 1, right? It doesn't go any higher or lower than that, right? And it is just asking about the parent graph here. So it would be, see, all real numbers between negative 1 and 1, inclusive, meaning those points do exactly touch negative 1 and 1. So we do include those. Okay, so the height of the water, h in feet at a boat dock, t hours after 7 a.m. is given by that. So it asks us to find the period of this. Okay, now, huge complicated formula here, right? You just got to know where to look for the period, right? The period ties in with my b value. Okay, so again, thinking about kind of standard trig equation here. A would be my amplitude, not asking about that. B corresponds with my period, and C corresponds with a phase shift, right? So whatever this B value is, it clues me into what my period will be. But it's not just pi over 60. You see that's not even an answer option. What I would do with this, remember it's 2 pi over the B value is my period, okay? So from this, 2 pi over pi over 60, right? That's the number in my B position, my coefficient of my variable. So that's how I would calculate that. Again, we said that dividing by a fraction is the same as multiplying by its reciprocal. So 2 pi, that should say times instead of equals. 2 pi times 60 over pi. Pi's will cancel, so 2 times 60, 120. Okay, so that should also be C for that. 57, so I'm told that angle B here is 39 degrees. I know that C is a right triangle. I know that side B is 48.8. I got to find the rest. So I can super easily find what angle A is here, right? I just do 90 minus 39 to give 51 for my A angle, because again, I know this one's 90, and so these two also have to add to 90. So A is 51, so I can get rid of answers B, C, and D right away. Now I have to find side length A and C. Here's something too, just a little, I'll still show you how to find it, but you notice just multiple choice strategy here. Your two answers were eliminated because they had the wrong angle, right? You know that A has to be 60.3 because your only two answers left have that as the value. So that's good to notice. So we know what A is, but I'll show you how to find that. Then you'd use Pythagorean theorem. But again, let's say we didn't notice that. What would we do? So again, we just pick an angle here, right? And so I want to find A. So I'm going to set up an equation specifically using tangent of my 51 degree angle. And why did I choose that? I chose tangent. Okay, you could do either angle, but I chose tangent because I want to know this opposite side, and I know my adjacent side, right? Opposite and adjacent. I don't know the hypotenuse, and again, I could find that first and that's fine, but you pick a side, pick an angle to go from, and set up a trig equation from that. So A should be equal to 48.8 times tangent 51. You get an answer of, like we said, 60.3, just like the answers told us. Kids who say, Miss Jones, why don't you like multiple choice math tests? That's why. You can just kind of look at the answers and not actually have to do the math. Anyway, so now we know A, and so Pythagorean theorem, now that I know two sides of a right triangle, I can find the third one, right? So 60.3 squared plus 48.8 squared equals c squared. So I get that big number, right? And then I take the square root of that, get about 77.57. So that'll be answer option A. Again, just a key, Pythagorean theorem only works for right triangles, okay? We're going to be getting into some problems that are non-right triangles. You cannot use Pythagorean theorem, okay? Last page, guys, we made it, and I filmed this all in about a 2-hour period, so you can imagine I am feeling great. Anyway, 58, so amplitude of y equals -3, whatever. So again, just remembering your equation. A is amplitude, B is period, C is phase shift. Okay, so again, A for amplitude. But guys, and so the amplitude here is going to be 3. You notice it says -3. You might be saying, what? Why didn't they have -3? Yeah, technically amplitudes aren't ever negative. It's just saying like that's the multiplier. That's the amplitude, the amount at which it was multiplied by. So what it would look like is that this would result in a vertical flip, but the amplitude itself, yeah, is still -3, or is still 3. 59, period of y equals 4 times cosine of 1/3 x. So similar to before, period. So again, dividing by a fraction, multiplying by its reciprocal, same thing, right? So 2 pi times 3/1, so that would be 6 pi. 6 pi period. This graph would be stretched out horizontally. All right, determine the phase shift. Okay, now, again, that's my C value, my number in this position, right? Now, what you have to remember is that minus means right, plus means left. Okay, so if it's minus pi over 2, it's going to move to the right. Again, in this situation, just like the other ones too, if you just graphed in your calculator y equals sine of x, and then you threw this in there, you could look at how much it shifted on the graph on the calculator too. Solve the triangle. Okay, so again, non-right triangle. So that means, again, Pythagorean theorem, no good, can't use it. Okay, same goes for this one. So for this, I look at my angles, right? 35 and 125. If I added that, I get 160, which means that, right, 180 minus 160 equals 20. So my C is a 20-degree angle. Again, that gets rid of a couple answers for me. So if I'm told the angles are 2 of the angles, it's easy to find the third one, right? But again, in this situation, I know all my angles, and I know one of my sides. So this would be a good situation for law of sines. Law of sines, I have my complete set that I called it, right? I know my B angle and my B side. So again, you have your law of sines formulas right on the page here, right? That's just the ratios, right? So B over sine of angle B. I want to find A and C, doesn't matter which one we find first. But again, I can't use Pythagorean theorem, so I'll have to use this law of sines little formula to find both. So that would be 7 over sine of 35 equals side A over sine of 125. Okay. And then again, in this case, I can just multiply over my sine 125. So in the calculator, I'll end up doing 7 times sine 125 over sine. And I got A, and so I'll do that. 7 times sine 125 over sine 35. So I get about 9.997. Let's just round that up to 10, right? So my A value is 10. And again, joys of multiple choice tests for you guys. You know it's got to be B. C, A is 10. Again, what you would do is set up the same thing to find angle C. You would do 7 over sine 35 equals C over sine 20. Same idea, 7 times sine 20 over sine 35 should give you about 4.17. But we know our answer is B. All right, last one. Solve the triangle. So again, in this situation, I don't know any angles. I know all the sides, but I don't know any angles. So in this situation, I'm going to have to use my law of cosines, right? And it's only giving you one, which is annoying. I wish they kind of gave you all three. But they're all variations of this, right? So let's start with that cosine of angle A. So let's, again, if I know all three side lengths, I can do that. So I have that. And I just need to substitute in the values that I know. So that would be 6 times 8. Okay. And then we throw that in the calculator. Okay, you don't have to do it in the calculator, but... So this is equal to 17 over 32. And so you might be saying, okay, is that the side length of, or is A, like angle A, is that equal to 17 over 32? No, you remember, again, this formula says cosine of angle A is equal to that. So we just found the cosine of angle A. So I need to do the inverse cosine of that fraction. So second cosine, second answer. So I get that angle A is equal to about 58 degrees. The sides and angles correspond with one another, right? So angle A is kind of in the middle, right? So you notice angle or side B is shorter than side C. So that tells me that angle C is going to be bigger than angle B. Sorry, I messed up. It should be C, right? Where angle B is smaller than angle C. Angle A is 58, angle B is 47, angle C is 75. And again, you would find that mathematically just by doing the whole formula just with B instead, and the letters are all switched around. But a shortcut there at the end. All right, there's the review. Good stuff.